Hi everyone, my name is Utesh Kumar Viru and today I'll be presenting my final project for applications for artificial intelligence. The project is called AI Quest Generator. It's a full stack web application that uses Google's Gemini API to automatically run any piece of text into an interactive multiple choice quiz. The core question I wanted to answer was simple. Can you take a state of art language model? I mean, like, wrap it in a well engineered application and make something genuinely useful? And I think the answer is yes, and I'm going to show you exactly how I got there. In the agenda, here's the roadmap for today. I will start with a quick project overview and show you the actual running application. Then I will walk you through my service selection original, the system architecture, the biggest technical challenge, my evaluation results I faced, the pros and the cons, and finally the lessons I've learned, especially how the project connects to the auto ML, like auto machine learning concepts we studied in this course. Let's get into it. So, what does the app do? So, from the user's perspective, it could not be simpler. You open the application, paste it in any study material, a Wikipedia paragraph, a textbook excerpt, lecture notes, anything, and click on one button. The app sends that text securely to the Gemini API, which reads it and generates five multiple choice questions. Each question comes with four answer questions, the correct answer, and an explanation. The front end presents those as an interactive quiz, one question at a time, with a progressive indicator. At the end, you see your score and explanations for anything you got wrong. You can see the input screen here on the right, like clean, minimal, and purposeful. Now, let me talk about why I selected Google Gemini as an NLP service, because this was not a random choice. The rubrics asks uh, for a clear reasoning on service selection, so I wanted to be thorough. First reason: instruction following quality. Google, like the Gemini 2.5 Flash is specially optimized for tasks that require the model to follow precise, structured instructions. A model that deviates from the format even once breaks the application. Um, like instruction following is not a nice to have here; it's a hard requirement. Also, the second reason would be the Google's Gen AI integrates natively into Node.js server, um, which made them secure architecture clean to implement. Third reason, I explicitly evaluated OpenAI 4.0, yeah, and Claude Sonnet as alternatives, but both are capable. But Flash was faster, averaging like 3.8 seconds versus over 5 seconds for the alternatives. And yeah, when a user is sitting there waiting for a quiz to appear, the difference is very noticeable. I want to spend a moment on the input data design because I think it is one of the most interesting decisions in this project. Rather than using a fixed data set, I built the application to accept any arbitrary text from the user. Also, it was intentional. The goal was to test the Gemini service directly. No fine tuning, no domain specific preparation, no curated data set, just raw user text and well crafted prompt. Also, I tested with Wikipedia articles, the text, yeah, the textbook excerpts, the science concepts or historical events, etc. The articles, news articles. The only constraint I enforced was a 50 character minimum in the UI. So to ensure the model had enough context to generate meaningful questions, this design mirrors a real world deployment scenario where the NLP service needs to generalize across everything. The system architecture is built on Net.js app router, which gives me a React frontend and a Node.js backend in one unified code base. Like here's how the data flows. The browser sends a post request to a server-side API route called Splash API. Splash generates quiz. That route, which runs entirely on the server, constructs the full prompt, calls Gemini using the Google SDK, processes the response, and returns only the quiz data to the client. The most important thing about this architecture is the security model. The Gemini API key lives in a .env local file on the server. It is never sent to the browser. The client never sees it. This is safe to deploy publicly, which matters for any like production application. On the front end, I managed four distant states using React's use state hook, the input view, the loading spinner, the quiz screen, and the result screen. This slide covers most challenging part of the project and honestly the most interesting from a technical standpoint. The problem is that large language models are trained on conversational data. When you ask them to return structured output, they do not just return it cleanly. They wrap it in a extra conversational text, something like "Here's your quiz. I hope this helps," followed by the actual data wrapped in the code formatting. When my server tries to parse that, it falls. It fails immediately. Before I solved this, roughly 15% of my API calls were breaking the parser. To fix it, I developed it. I developed what I call a like three-layer solution. Layer one is system level prompt that assigns the model a specific role, expert educator, and explicitly instructs it to return only the raw structured data, nothing else. No extra text, no formatting wrappers. Layer two is the user prompt itself, which provides the input data and specifies exactly what fields I expect in each question object. The question text, four answer options, the correct answer, and the explanation. Layer 3 is a server side safety net. Even after all those instructions, I automatically ship my residual formatting on the server, like before the data get parsed. All the three layers were in place. My success rate hit 100% across all the subsequent test cases. The lesson: one instruction is never enough when you are relying on a language model for a structured output. Unit defense in depth. Here's a quiz screen in action. You can see quiz 1 of 5 at the top with a progress indicator. The quiz was generated entirely from this photosynthesis text I pasted in. The model read it, understood it, and produced questions that directly test a key concept. Four answer options are shown. The question at a time format is intentional. It forces engagement with each item rather than letting users rush through. The animated transition between application states were built using the Framer motion, a React animation library. It gave the app a polished, like professional feel without requiring complex custom like the CSS work. Small details like this are what a separate working prototype from a finished product. And here's the result screen. The score is displayed like prominently at the top. In this case, 2 out of 5. Below it, each question is color graded: green for correct, red for incorrect. For every wrong answer, the explanation generated by Gemini is shown right there in line. That explanation feature is something a traditional rule-based quiz generator simply cannot do. It requires genuine reading comprehension, not just sentence detection. The model understood what the text was saying and can now explain why a given answer is correct. You can also see the powered by Gemini AI attribution at the top. I kept that there as transparent AI disclosure, which I think is a good practice. Now let us look at the evaluation results. I tested the application across 20 input passages spanning different domains and lengths from 100 to 1200 words. 18 out of 20 runs produced well-formed, accurate quizzes. The two failure both occurred before I finalized the prompt solution and were caused by formatting issues in the prompt itself, not model capability limitations. So yeah, I accessed question quality across the 3 dimensions. Relevance was high across all 18 successful cases. The the questions directly texted concept from the source text. Accuracy was also high. Correct answer matched the source material with no factual errors observed. And distractor quality was rated medium. For shorter inputs under 100 words, the model sometimes generates options that were too obvious. For longer, richer inputs, the distractor quality improved significantly. The overall verdict: Gemini is highly feasible NLP backend for this specific task. On performance, I measured end-to-end latency across 15 API calls with input lengths across, ranging from 100 to 1000 words. Minimum was 2.1, average was 3.8, maximum was 6.7 seconds. Importantly, input length did not consistently drive latency. Network overhead and model queue time were the dominant factors at this scale. After my prompt fix, JSON parse successful rate was 100%, and when I compared this to rule-based quiz generators, the LLM approach produces far richer, more valuable output at the cost of latency. For educational software, that trade-off is absolutely worth it. On the pros side, the API proxy security pattern would exactly have worked exactly as designed throughout all testing. The multi-layer prompt strategy brought the parse failure rate from 15% down to zero. The Framer motion made the user experience feel genuinely polished. Tailwind CSS v4 allowed rapid iteration. I could completely restyle a component just by editing class strings. And Gemini produced high quality questions across every domain I tested without any fine tuning. On the challenges side, the naive single instruction form failed too. Too often before the fix. Short inputs under 100 words produce weaker questions. Excuse. And I hit free tire rate limits during heavy testing sessions, which would require a paid tire to address in the production. So this is a slide I think matters the most for me in this course. The rubric specifically asks about AutoML lessons, so let me connect this project directly to that framework. Using a pre-trained language model via API is functionally equivalent to using an AutoML platform. In both cases, you are not training a model; you are configuring a system either through a prompt or through training settings, and then evaluating the outputs. The skills required shift from data science toward what I would call output engineering. Lesson 1: structured output needs multiple constraint layers. One is never enough. Lesson 2: non-determinism excuse me, is a design constraint, not a bug. The same way AutoML runs produce different results across different seeds. Lesson 3: the LLM API is AutoML at the application layer. No training, but the same rigor is required. Lesson 4: input quality drives output quality. Garbage in, garbage out, exactly as in classical ML. Lesson 5: security architecture must be established from day one. It cannot be retrofitted cleanly. These lessons generalize to any LLM powered application that you'll ever build. I grounded this project in 5 scholarly sources. So yeah. So to close, Gemini API is a proven and feasible NLP backend for interactive educational applications. The engineering challenge in this project was not model selection; it was prompt engineering and output validation. Those disciplines require the same systematic rigor as traditional machine learning, just applied at a different layer. LLM API represent AutoML at the application layer, and understanding that equivalence is one of the most practical skills you can develop as an AI practitioner right now. I hope this project demonstrated that clearly. Thank you for watching.